Howdy folks. We're going to continue with learning about solving rational equations. And what we've just done before is we solved rational equations where there's only one rational expression. Here in this one we have two rational expressions. We have 4 over x minus 2 and we have negative 1 over x minus 5, right? So remember that the main tactic that we're learning is the way we're going to solve these rational equations is by canceling the denominators. Okay? So now there are other ways of solving them, but that's the way that I'm showing you. Now we could, since we have two denominators, we could cancel both of the denominators simultaneously, but I'm actually not that interested in canceling both of them simultaneously. I prefer to do things one at a time. It takes an extra step or two, but I think it'll make it a little bit easier to understand. So let's go ahead and try this. So we've got this denominator x minus 2, and we know that the way you cancel a denominator is you multiply by the denominator. But if I multiply this by the denominator, I also have to multiply this by the denominator, and I also have to multiply this by the denominator. So I'm going to multiply all the way through by x minus 2. I'm going to multiply this by x minus 2, I'm going to multiply this by x minus 2, and I'm going to multiply this by x minus 2. Now over here, it's simply going to cancel the denominator, and we're going to bring down the 4. Now here, we're going to distribute the negative 1 to the x minus 2. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2, and that's going to equal. Now here, this negative is kind of on this 1. In fact, we can move that negative up to the 1. So we've got negative 1 times x minus 2. Negative 1 times x is negative x. And negative 1 times negative 2 is positive 2 all over x minus 5. Now look at this. We can actually clean this up just a tad. We can combine the 4 plus 2. 4 plus 2 is 6. So what we now have is 6 minus x is equal to negative x plus 2 over x minus 5. Now we're down to one denominator, right? So we're going to multiply by that denominator. I'm going to go x minus 5 here, x minus 5 here, and times x minus 5 here. Here is simply going to cancel the denominator. We're going to have equals negative x plus 2. And here, we're going to distribute the 6, and we're going to have 6x minus 30. And here, we're going to have negative x times x is negative x squared, and negative x times negative 5 is plus 5x. Now we can combine a couple things over here. We've got a 6x and a 5x. That makes 11x. And so we got a negative x squared plus 11x minus 30 is equal to negative x plus 2. Now, I want to move everything from here over to here, and the reason is because this is a negative x squared, and I would prefer a positive x squared. So I'm going to add x squared to both sides. Add x squared. That's going to cancel here. Then I'm going to subtract 11x from both sides. Subtract 11x. That's going to cancel here. Then I want to add 30 to both sides. That's going to cancel here. Add 30. And now this side has zeroed out. And here I have x squared. Negative x minus 11x is negative 12x. 2 plus 30 is 32. This is not a 36. This is a 30. It's just the way that I wrote it. It looked wrong. Okay? So, now we're going to, this is factorable. And so, what I'm going to do is, I'm going to have 0 equals, two numbers that multiply to 32 but add up to negative 12 are negative 4 and negative 8. So this is going to become x minus 4 times x minus 8 is equal to 0. Set each one of them equal to 0. X minus 4 equals 0. X minus 8 equals 0. And we have x equals 4 as one of our solutions. And x equals 8 as our other solution. And our domain restrictions are x cannot equal 2 and x cannot equal 5. Neither one of those numbers came up as our solution, so we don't have any extraneous solutions, and we're done. Okay? So that's our first one. Let's do another one in just a minute. All right, here's another one here. Do you want to pause the video and try it yourself? Go ahead, try that. Go ahead and pause it and see if you can figure this one out on your own. All right, let's see what we got here. So we're going to cancel this denominator. So we're going to multiply by x minus 4 all the way through. Multiply by x minus 4. Multiply by x minus 4. Over here, it's going to cancel the denominator. And we're going to have 10 plus 15 times x is 15x. 15 times negative 4 is negative 60 over x minus 8 equals 5 times x is 5x. 5 times negative 4 is negative 20. All right? So now we want to cancel the x minus 8 here. So we're going to multiply by x minus 8 here, x minus 8 here, and we're going to multiply this binomial by x minus 8. Note that I have to put parentheses around this to multiply by x minus 8 because I'm multiplying by the whole side. Okay? So then here, 10 times x minus 8, 10 times x is 10x. 10 times negative 8 is negative 80. Now here, it's just going to cancel the denominator. And we're going to bring down the 15x minus 60 equals. Now we're going to have to distribute here. 5x times x is 5x squared. 5x times negative 8 is negative 40x. Negative 20 times x is negative 20x. And negative 20 times negative 8 is plus 160. Now we can clean some things up here a little bit. We've got 10x plus 15x. That's 25x. I've got negative 80 minus 60. That's negative 140 equals 5x squared. Then I got a negative 40x minus 20x. That's negative 60x. Then I have plus 160. So now I can move all these items over here. So I'm going to subtract 25x because I got to set it equal to 0. It's a quadratic equation now. It's got a square power, right? So I've turned my rational equation into a quadratic equation. I have to set it equal to 0. Minus 25x minus 25x. That cancels. Add 140. Add 140. Oh, this is 100. Sorry, this is 160. Sorry about that, folks. That's 160. Add 140, and I get, bring down the 5x, I get 0 equals, bring down the 5x squared. Negative 60 minus 25 is negative 85x. 160 plus 140 is 300. And now this is, well, we're going to find out if it's factorable. So we've got a common factor here. 5 can be divided out of here, here, and here. Okay? So if we divide out 5, we get 0 equals 5 times x squared. 5 into 85 is 17. So minus 17x plus 5 into 300 is 60. And now we're going to look for two numbers that can be multiplied to 60 and add up to negative 17. And those numbers are negative 12 and negative 5, right? So we've got 0 equals 5 times x minus 12 times x minus 5, right? Because negative 5 times negative 12 is positive 60, and negative 5 plus negative 12 is negative 17. We'll take our two factors. We know the 5 can't make this equal 0 because that's not 5x, it's just a 5. And so it must be true that either x minus 12 is equal to 0 or x minus 5 is equal to 0. If we add 12 to both sides, we get one answer of x equals 12. Add 5 to both sides, and we get another answer of x equals 5. And there's our solution for that one. We're going to try one more, okay? All right, folks, here's another one. Why don't you pause the video, try this one on your own, and see how it turns out. All right, let's see how you did. I've got two denominators here. I want to cancel each one, but I'm going to do them one at a time. I'm going to cancel this one first, okay? Let's multiply by x minus 5. So we're going to multiply by x minus 5 here. We're going to multiply by x minus 5 here, and we're going to multiply by x minus 5 here. X minus 5 times 1 is x minus 5. Here, x minus 5 is simply going to cancel the denominator, and we're going to bring down the minus 3 equals 4 times x minus 5. 4 times x is 4x. 4 times negative 5 is minus 20 over x minus 3. And now we can combine this, see the minus 5 and the minus 3? We can turn that into x minus 8 equals 4x minus 20 over x minus 3. All right, so now we're going to cancel this denominator, we're going to multiply by x minus 3 on both sides. I can multiply it. Now look, this is actually a binomial. It might be easier just to multiply the whole thing by x minus 3. You could instead just simply multiply the x minus 3 times this, x minus 3 times this. Okay? And if you were to do that, x times x is x squared. X times negative 3 is negative 3x. Now, negative 8 times x is negative 8x. Negative 8 times negative 3 is positive 24. On this side, it's just simply going to cancel the denominator, and all we have left is 4x minus 20. Now over here we have a positive x squared, so I'm going to leave that there. I'm just going to leave the positive x squared. I'm going to combine here, so I'm going to have x squared. Negative 3x minus 8x is negative 11x plus 24 equals 4x minus 20. Now if I add 20 to both sides, remember I got to set this whole thing equal to 0 because it's a quadratic equation. Add 20 here, add 20 here, subtract 4x here, subtract 4x here. This is going to cancel, and I'm now going to have x squared minus 15x plus 44 equals 0. Now this is factorable. Two numbers that multiply to 44, positive 44, but add up to negative 15 are negative 4 and negative 11. So this is going to become x minus 11 times x minus 4 equals 0. Now we just set each one of these factors equal to 0. X minus 11 equals 0, and we get x equals positive 11 as a solution. X minus 4 equals 0, and we get x equals 4 as a solution. Our domain restrictions are x cannot equal 5, x cannot equal 3, and therefore neither one of these solutions is a domain restriction, so we do not have any extraneous solutions, and we're done. Well, that's it. Hopefully this is enough. These three examples should be enough for you to sort of get your feet wet and understand solving rational equations, and let me know if you have any questions, okay?